Wait, so if I do this, hopefully now you guys should hear me. Wait, so if I do this... Oh! Okay, yeah. Yeah, okay. You guys can hear me now. You guys can hear me now. Hello, activation. Oh my god. Okay. I see. Oh my god, there's so many. Wow, okay, so... Wow. Oh my god, there's so much... There's so many more people than I thought there would be. Wait, let me start the music again. Wow, that's so interesting. I didn't think there would be that many people here, especially since like the choice kinda dead. I mean, no, I don't think it's dead. It's just it's not very active. So that's awesome. As always, so fixing my images. No fixing. How are you? How are you guys doing? Before everything, before anything, let's just start with that. I didn't think. Oh my god. Alright, then I guess we're also gonna start the stream. So I wanted to stream a bit because like I've been cutting a lot of things, and I'm like, what's it called? I don't know. I just want to, well, actually do things on stream as well, like make content at the same time that I'm making content. It's like I'm like doubling the amount of content I'm making. I'm making content while streaming, so I make content while making. It's awesome. Yo, Rexstone as well, and then good that you guys are doing well. Salut mon gars, salut d'orage. Sorry, we're gonna speak English mostly in this stream. It's just that I also speak French for people that don't know. Yeah, I guess I could show you guys what I've been up to. I've been up to a lot of things. However, I can show what we're gonna be doing on this stream. So you maybe have seen the thumbnail. So let's just go in Minecraft real quick. So it is this thing here. So it doesn't look that good. I think it kind of looks good like that, but like it's not really it's not, doesn't look that good yet. Because it actually looks good when you turn on shaders, and also when you have the right resource pack. Hold on, let me get the right resource pack. Where is it? Right here. I think this one. All right. So, and now look at that. Look at that. That looks so good. That I'm pretty proud of this. I think that looks insane. So yeah, I'm pretty proud of how this sphere turned out. There's a little hole here. Wait, here. Well, don't. I can fix it. It's fine. It doesn't matter too much. But yeah, that's what I've been coding. So I've been basically silently developing some technology to actually build Minecraft worlds using your GPU, using your graphics card, because it's like 100 times faster than if you're doing it doing it normally. Indeed, Rex, it does not even look like Minecraft anymore. So for you guys to kind of like understand the sheer scale of that thing, it's 32 chunks across. That means that like if I make a hole like here, like I have 32 of render distance here, and if I just go like slightly out of the sphere, the other side should disappear. Yeah, it's 32 chunks across, so it's like 500 blocks by 500 blocks. And now you may be thinking that like, if the sphere is 500 blocks high, how do we fit it into like a normal Minecraft world? Because a normal Minecraft world is like 384 blocks tall. So how do you fit it in there? Well, you just increase the height using a data pack. So if you, it takes a while. I'm at like max speed in spectator. It takes a while to move, but yeah, if we press F3, well, actually like height 600, and I can go up to 1000. So I have enough space. But yeah, that's the first thing that I've been up to that we're gonna do in this stream. Because the second thing I've been up to, this is for one project, and I've been doing a lot of things for that project. Wait, but do you generate the chunks ahead of time? Do you generate or save file chunk gen on the GPU? No, I've been making schematics with the GPU max. Basically, so yeah, if I do schem list and like the latest schems I have, these schems here have been created with the GPU, and then I paste it in the world. Implementing chunk gen in Minecraft using the GPU would be freaking crazy. That would be awesome. But making schematics with the GPU would already be awesome, is already good enough. So when this whole sphere would take like 12 hours for my CPU to like compute, it actually takes 4 seconds with my GPU. So I mean, this is like 500 times 500 blocks. So like, you know, you gotta use the GPU for that kind of shit. But yeah, so here is the sphere. I'm gonna let you guys have a last look at it, because there is something else that I want to show you that we're gonna like talk about a bit more. I want to get hello. I want to get good. So we are basically, I'm basically presenting the project that we're gonna continue today. That is basically gonna be one of my next videos. It's for sort of like more story-driven, story-told type of video, and so I need a good build for that, and so I'm basically showing the build I have so far for the video. That's what's going on, and then we're gonna start coding very soon. Rexton, what GPU is? I'm using I have a 3070 Ti, but I'm pretty sure like if you use like a 1060, for example, it would take 8 seconds to generate this entire thing, so it's still like very, very fast. I think the GPUs are just like fucking insane anyway, so yeah. So I think you guys have seen that like there's like a disk in the middle, right? Like a disk. It's like resting. It's like flying. It's floating. So what is it? What is that? What is that disk? Basically, this entire sphere is supposed to be a sort of like simulation in my video. Thank you, Rexstone. See you around, and thank you for popping by. So this disk here is basically gonna be a sort of town on top of it. Is it using CUDA or OpenCV? CUDA. And I'm actually using Python, so it's like it's kind of cool. Yeah, it's using CUDA. Wait, hold on. So I'm just gonna end my explanations, okay? So yeah, this disk, there's basically gonna be a town on it. It's like this whole thing is supposed to be in sort of like futuristic kind of simulation, and like on top of that disk, you know, you have like buildings or whatever, and basically how can I segue to the next idea? So basically at one point in my video, this whole like build, this whole town that's gonna be on that disk is supposed to like fall apart. It's like supposed to all the buildings like are supposed to like tumble over and just like die kinda. And I actually already coded that, so I'm gonna show you guys how that looks. I'm just gonna do that. All right, so if I do function town animation, and then what's it called, Start? No, play. Yeah, okay. When I'm gonna do that command, you're gonna see like a whole town fall apart. It's gonna appear and it's gonna fall apart. So let's see how that looks real quick. So, bam. All right, we go to town, and very slowly you're gonna see those builds here. Yeah, they're tumbling over and are actually falling through the disc, and they're like emancipating underneath here. How cool is that? How cool does that look? Look at all that. Wait, hold on. It's okay. It's taking a bit to update, man. I think that looks sick. I think that looks super sick. I just need to allocate more threads so that the animation is more fluid. But yeah, we actually hold on, let me update the entire thing. Yeah, that's like how the town collapsing kinda looks like. I'm gonna play it again with more threads so that the animation is like looks better, so that like blocks far away can update. But yeah, and actually traversing the thing. And that is, I think, is extremely interesting as well, because this entire thing is completely vanilla. So this is Datapack doing this. It's lagging the frick out of my game, but it is a Datapack doing that. So it's entirely vanilla. And this animation was also generated on my GPU as well. Like the data pack for the animation was also generated on my GPU. So I like made it so that I can make schematics with my GPU, but also animations, which I think is super sick. So now, what's next? All right, I'm not gonna spoil the entirety of the video. This is gonna revolve around, but we're basically in the middle. I'm gonna go on paint for that. It's gonna be easier. You basically have a disc. So this is the sphere, right? This is the sphere. I think you guys can understand that this is a sphere. And then you have a plane like that, and then here you have the town, right? You have like the wee. All right, awesome. And in the middle, I kind of want, I'm not exactly entirely sure what I want, but I want like a circular kind of pillar in the middle that goes from like top to bottom. So like in the world, so if I go TP in the middle and then I do H cylinder, what's the argument? So yeah, radii 31 I think it was, and then height I don't know, 50. But then hold on, let me go down. Ugh! Let me go down there. Neo. This is so huge. This takes so long to fall through. If I do this, I basically want a sort of beam in the middle. Oh yeah, that's kind of cool. I like the shape at least. Yeah, I want a beam traversing the sort of like simulation. You know, that's kind of what I want. And so I kind of need to make it. I kind of need to make that beam, and that's gonna be what today's stream is gonna be about. We're gonna make that beam using the GPU, and hopefully make something really big and make something really cool. That looks really cool. That's kind of the idea. Sorry if I repeat myself a lot. I don't really know how to stream, so I need to fill space. So yeah, the project is this one. There's already quite a bit done in there. So you got you got all of that. You got where's the other things? Sphere making is another big file. New. So that's gonna be very interesting. So let's get to making whatever the fuck that beam is, using the GPU. Let's go. Let's do that. So, okay. First thing we need to do is we need to... I kind of want to create a new file for that. So sorry for people that don't really code. right? Because you guys are not gonna be able to follow too much, but hopefully seeing the cool build should be enough. So the first file, yeah, there's gonna be beam making a py. Awesome. Bap bap bap. Beam making a main. All right. So if you guys see any bad things I'm doing with Python, feel free to tell me that I'm doing something wrong. All right. Because I'm not an expert at Python, so that's gonna be it's very interesting to know. So how do we make a big beam? So the main idea is that firstly it's gonna like, I don't know, the whole process is gonna resemble, oh, we'll be using an SDF for an infinite cylinder. So Max, very interesting question. Actually, I think I'm gonna be using an SDF for that. Also very another thing that you may like, Max, if you like the town animation, is that if we go into town making, whatever, where is the, yeah, town animation here, it's actually the, what's it called, the rectangles that serves for the builds are actually what's it called, are actually SDFs as well. So like, yeah, these are like SDF boxes that I then like turn as well. But what's awesome is that since you're doing it on the GPU, it just like, yeah, it's like feasible. Do you plan on taking to Rock API for GPU computing acceleration? Dimitri, I'm not sure if I want to do that. CUDA has been really good, honestly, so I don't think I'm gonna change API for now. I really like CUDA. Hey, El Puleto, I'm coding. Okay, for any new viewer, I'm basically making a map for what's it called, my for my newest video, as the title suggests. And the thing is, I'm not a good builder, so I'm using code to like generate cool things. All right, and right now we're making a big beam that is traversing this entire sphere. That's basically it. Yo, hello Queenie. Thanks for popping by. Have fun at work. I hope work is not too boring. All right, so let's get making that freaking beam. So, okay, it's gonna get a bit technical, but the way like building with a GPU is basically like so I have a 3D array. Let's say, I mean, I just have an array with like integers which are like basically blocks. So 0 would be air, 1 would be stone, and stuff like that. And then I just like modify this array using the GPU. And then once I'm done, I put this array. Once I'm done doing the GPU thing, so GPU, and then once I'm done modifying it with the GPU, I put it into a .schem, into a schematic, using my library, using a Python library. If you guys don't know, I made a Minecraft library, a Minecraft Python library, which is called MC Schematic. Okay, I'm gonna write it. It's gonna be easier. So MC Schematic, which makes you able to make schematics through code. So check it out if you guys want to make schematics with Python code. It's pretty fast. I tried to make it really fast, even though it's in pure Python. If it was written in like C Python, it would go way faster, but it's good enough for a lot of applications. All right, so let's get building. So I just need to make that cylinder. I'm gonna use the same process I did for the sphere, as I need like all the code from the sphere, and I just choose what I need from the sphere. Bro, how is your accent so good? Mine is just filled with French R and TH. Yeah, Mine did too. Mine did too. I remember at the start when I started speaking English, it was absolutely horrible, and it was also with other French people, which was kinda interesting. But thank you for the compliment. It's just, I guess it's just practice, and every time hanging out with like English people that are willing to like ask if you want feedback on your accent, and that like also wants to, how is it called, that also wants, yeah, to help on your accent and stuff like that, is really good, because I make so many mistakes still, and you learn every day. So all right, let's take the sphere thing, let's put it into beam making, because that's what we're doing. So beam scam pop, no, def beam scam bam bam. All right, wait, no, that's wrong. I need to do this and then do beam scam. All right, so now I'm gonna need to import everything, so that's gonna be extremely fun. Actually, I can just go like sphere up here, and I can just I just I'll just take everything. Pop. All right, and now everything should be here. All right. So now I'm going to make an advanced English class, and to take an advanced, and I like to break small still. Anyway, thanks for the tips. No worries. Good luck on that. Yeah, I mean, just get friends that wants, that knows that you want to get better, and that wants to help with that, and you're gonna get so good so fast. It's crazy. It's crazy. Also, another thing that I started doing is that I started thinking in my day-to-day life in English, meaning like anytime I'm thinking of getting food, or like anything in your daily life that you want to do, you like say it in English. Anytime you think about something, anytime you wanna talk, anytime you're like imagining conversations between like you and your mom, or like whatever, just do it in English. And maybe native English speakers are not really like, they can't really relate, but like, yeah, try to think always in the language you're trying to learn. And oh my god, is it good. It's crazy. It like yeah, just speak English all the time in your head, so you're gonna get extremely good doing that. All right, so that's gonna be a bit boring here, but we're just gonna I'm just gonna refactor the code to like, I'm gonna refactor the code from the sphere to do the beam thing, so that I don't like start from scratch. So make beam, pop, make beam. Hold on, there's like the song, I don't want it to be too. All right. Shit, wait, hold on. Where's my stream? I don't know where my stream is. Okay. Thinking in English is a problem for me because I start speaking right in English randomly in the middle of French. Yeah, I know. I started doing that when I was in high school, and I started speaking English in the middle of answering the teacher's question so many times. This was horrible. this was horrible, but it's worth it. You know what? Take the embarrassment once, twice, and it's fine. Like we're not. It's not the worst thing in the world. So, so this is the sphere code. So let's just refactorize it, repurpose it. Let me check. So there's like some gradient stuff. I don't really want gradients. Oh yeah, so I'm filling up arrays like these, so people that know Python, just like don't mind this. This is how CUDA wants you to do it. I can't do it otherwise. I tried, but I can't do it otherwise. Main body of sphere on sphere edge. I'm just gonna like I'm just gonna remove everything. You know what? I'm just gonna remove everything here. All right, we're gonna start fresh. We're gonna start fresh. Will you be my uncle, dear Slow me? I'm sorry. I don't think our blood are any related. are related enough for that to happen. But good luck though in finding an uncle in your endeavors. So alright, so end of the GPU the fuck that right? Programming. You know, I'm gonna keep programming because it's funny. Alright. So GPU start, make beam, and here's the world is gonna be converted into a schematic. Scam, and here you put the scam. So I just need this to change here. Do I probably don't. Oh, big sphere, big beam. Let me go up here. So world size. So the world size. So okay, the beam. Since we're making a schematic, we need to know the dimensions of the schematic. So let's see. So this beam is the one I want. It's like the size I want. So all right, let's see how big that is. Just gonna go like new. Oh my god, there's a lot. Hold on, guys. There's a lot. There's a lot of wind. Hold on. Alright, good. Sorry. Okay, I'm back. There was a lot of wind. What are you coding? So, I'm basically making, for my new video, I need big builds. And thing is, I'm not a good builder. So, I'm letting my computer do the building instead. So that's what we're building right now. We're building actually a big beam going through this like entire sphere. That's what we're going to be coding today. So first let's take dimensions of the beam because it needs to be put in a schematic. So so we need the size of all that. Alright, so in X and Z it's 63 by 63 and I would assume it's by 500. So if I go down here, let's go down there. New. Alright, see ya, El Poletto. Thank you. How is your controls AQSD? Will you play with keyboard sideways? Mr. Oddfox, have you ever heard of French keyboards? Or just European keyboards for that matter? This is I'm actually using an AZERTY keyboard. So that's why it's kind of weird like that. I do not play with my keyboard sideways. But it's kind of funny. So okay, this is 63 by 63 by 500. I know it's actually 480. So we're gonna put that. So it's going here. So we got so we got fuck. Yeah, 63, 480, and 63. AZERTY for the win. Yes. Do I ever get Ripper with the code? Should be interesting to see. Unfortunately, I mean I do. So that it's like saved. Unfortunately, it's private. I don't wanna release it yet. I'll probably release it with the video. I have to think about it. Like when the video will come out, I maybe will. I don't like sharing my code too much. I've never been a big code sharer, to be honest, but I think I'm gonna need to do it at some point because it's cool. It's a cool thing if you guys can take a look at it and be interested. So yeah, I'll definitely think about it. So Perlin dim. Oh yeah, implemented some Perlin noise in there. Blocks and okay. So now that we have the block, oh wait, hold on a second. Divided by 2, and this is 63 divided by 2. But then I need to actually need to seal it. I think probably do. Okay, that's fair. Gotta be patient. Yeah. But again, maybe I won't share it. But if I share it, it's gonna be in the description. So go take a look there. So. Alright, so we got our scam. with the correct offsets. I'm not gonna go into details where they are offsets like these. You just know that there are. So theoretically now, if I run the program, we should get a schematic that has nothing in it. It's like it has the right dimensions for the beam, but it has nothing but air in it. So let's see. Hopefully. Jeep. Oh god. Oh, what did I do? Oh no. It's a CUDA error. It's a CUDA error. Oh no. Break. Oh no. We don't like CUDA errors because it's extremely annoying to understand. So def random flow. Oh no. Is that bug again? Wait, random flow, it's like here. It's like, yeah, I think it's cheating itself because it doesn't know what F32 is. Can I just do F32 equals np.f float 32? Please, 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 please. No, it's still shitting itself. Oh, maybe because it doesn't know that it's not constant. If it's here, doesn't know it's constant. I'm sorry, I've been dealing with that kind of shit a lot. It's kind of annoying. Okay, you know what? We're gonna do it differently. We're gonna be GigaChats about it. I'm just gonna replace every time we see F32, we're gonna replace it with with np.float 32. It's annoying. I don't like doing it, but I don't really know how to solve that issue. So we're just gonna do it. Alright. Float 32 everywhere. So now, if I run it. Oh, did I not have to do that? Oh my god, that's gonna be so annoying. Okay, that's one of the problems with working with the GPU, is that you don't really know what's going wrong. It's horrible that you don't really know. I don't. Oh my god. The thing is, if that doesn't work, then it's just gonna. It's like, okay, the NP array is here. Oh my god. It's starting. The thing is, it's a bit annoying. Because, like, I don't want to spend the stream debugging whatever that is. Right? I'm not interested in doing that. But we're gonna have to do that at least as fast as possible, because holy crap. Can't compare random value was random value is here, and a function that may escape. Oh my god, what is this? Okay, what if I don't want randomness? Alright, what if I'm not interested in randomness? Does it just still continue with working? Normal curve, and here it's basically shitting itself. What about if I do this? Let's be GigaChats about it. All right, maybe it's this that it's like, no. What's wrong with this? Oh my god, wait, what's wrong with this? Oh, the value for F32, as there are multiple definitions. Okay, that's gonna be a bit annoying, but so F32, it's shitting itself because it doesn't know if F32 is gonna say constant or not. But if I do F32 is equal to np of float 32, we should be fine. Please, please be fine. No, fuck. Uh oh. But like, the thing is, it's not screaming at me here. It's using F32 there. It's not screaming at me. And now, oh, maybe it's not screaming at me here because it's never using it. Okay. We're gonna... We're gonna do the thing I wanted to do at the start. Let's see. Well, Alright. So now if I... Please work. I swear to God, I'm just gonna like... I don't understand. It's starting. You're casting in both of those functions with F32. You think that's the bad thing? Let's see. I am. So what if I don't cast to it? Well, I mean now, if I put it back, now we good. So maybe yeah, it didn't know what to cast with. Oh, no, it knows. Oh, let me rename that. Let me rename like this to R&D state. R&D state. All right. If I do this, what happens? No. Random value. It doesn't understand whatever the frick random value is. Okay, that's gonna be fun. That's gonna be really fun. Random value. It doesn't know what random value is. I mean, it knows, but it cannot capture constant value. It's not. You cannot use any old Python. The thing is, this code works for the sphere. That's one of the big problems. But if I just like remove stuff at the bottom of the function, it works. Cause like yeah, like for example, you see, if we go in sphere, right? Sphere is where I make the sphere. It's like this entire thing. The code is the exact same, just with more things, right? And if I create a sphere live, if I do sphere making main, I don't have that problem. You see this? I'm getting no errors. The code is the same or even worse, right? The code is even worse, yet there's no problems in making the sphere, which is kind of crazy. I don't exactly understand why, right? Because it makes sense that maybe a function can like escape the GPU bounds, as you're saying, right? But I don't understand how it is escaping here and not escaping in sphere, right? It's escaping in beam, but not escaping in sphere, which is like the weirdest thing that I tried to debug the other day that I just can't. It's just, I don't get it. You know what? Let's just chat GPT this real quick. You know what? I'm feeling like chat GPTing it. Maybe it's gonna know. No, actually, it actually did not know that time, so it's probably not gonna know. Hello, Germany. We are coding some pretty builds today, when the program actually wants to work. That'd be awesome. So yeah, so maybe a CUDA random function. Keep in mind, you did not finish the CUDA random function. I mean, there is definitely is there NP? I could probably use NP random. Can you use NP random? Wait, CUDA how is it called? Supported functions Python. Let's find out. Supported features in CUDA. So standard library, you have all that. Is there a random in there? Maybe. No, however, there's a random number generation. Do they? What? There's a really thing here. Given that the code you rewrite in GI to GPU kernel might not. Yeah, exactly. But that's like the weirdest thing. Because again, in the sphere, there's even more code than that. And like the thing is, I really can't really know what it's GI'd to. So that's the main problem. I really can't know what is gonna be GI'd to. Okay, I'm gonna try something kind of crazy. Hold on. So where's the error right now? The error is at random float, alright? I'm gonna try something that's kind of crazy. What if I do this? Oh my god! Okay, we might. If you call the function, it's not gonna be a problem anymore. Okay, that's interesting. That. Okay, we're gonna call the function then. We're gonna call the function. I don't care. It's running on the GPU. It's fast enough. I don't mind. I don't mind. I don't mind. It's horrible. It's horrible code, but hey, look. That's funny though. That's very funny. We're gonna do that. We're gonna do that. So let me uncomment this, and I'm just gonna pull random flow. Python is so, I know. Python and CUDA are so strange. I don't get it. And oh look, I called random flow, and there was no other errors. What the hell, man? That's so weird, but we fixed it, and we're finally gonna be able to actually build something. Look at it, we're actually gonna build something now. Okay, awesome. It it just took like 20 minutes. Alright. So now the GPU is done, whatever. And so if we go into our recent schematics, we can see we have a big beam schematic here. Thing is, it doesn't have anything in it, right? It has one block that is air. It's very probably just air. So like, yeah, it's just air. Now a week from now, you're gonna wonder why you call it and take it out. That's so true. Wait a second. Wait, you're so right. Hold on. You're so right. Avoids CUDA GIT error for some reason. Yo, thank you. Thanks so much. That's yeah. Okay, that's good. That's a good thing. That's a good thing to know. So, alright. So, let's make a beam. So, first, let's take the SDF of beam. So, the SDF of beam, actually, Mr. Max sent it earlier, so I'm just gonna take it. You know what? No, I can do it. I'm a big boy. So, I can do it alone. So, let's see. I'm not sure how to. Well, first, yeah, I can make a function that is like def is on, what's it called? Alright, CRL. Have a good eat. Hello, Nihi. We are coding some pretty builds. So for any new viewers here, to be very brief with it. I'm not a good builder, so I'm letting code build for me. So we're coding something to build a very beautiful beam in the middle of that sphere. That's what we're doing. I'm not gonna go into details with it. You can always rewind, maybe that could help. But yeah. So def is on cylinder edge. So and we got a tolerance. Look up IQ SDF. It's actually what Max. It's actually Max is actually what I'm doing. What I did for the box SDF, for example. Yeah, IQ is crazy with SDFs. I'm really glad you're also an SDF enjoyer. Yeah, SDFs are crazy, and IQ is a legend. Kubeflow, why are you coding for Minecraft? I'm coding for Minecraft for my newest video. And if you're talking about the practicality of that thing, this takes 4 seconds to generate, instead of like a week to build by hand. So I think this is a very good reason. I think that's a good reason why I'm coding for Minecraft. Alright, so it is on cylinder edge, and it's gonna return a boolean. Wait, so tolerance. I guess I can just yeah, ray marching and intro. Yeah, ray marching was my first introduction to shaders. That's really cool. Alright, so we're gonna have to define some variables like cylinder radius, which is gonna be, we're gonna make it float anyway. So the cylinder radius is like 31, something like that. And then so so if we have, if we have, imagine we are looking at our schematic from the top part, from the top. So we have like, let's say we have a grid that's like 5 by 5, like this. We want those. Imagine the cylinder has like a radius of 2. We want those to be on. How the hell use Python in Minecraft? It's a very big talk. But like I can't go into details into it, but yeah, I've been making a technology to do that for a while, so it's pretty cool. So the middle is at 2.2. I want 2.5. I do want 2.5. So actually, well, okay, we're gonna calculate the middle. So middle x of schematic is gonna be so I believe I have an x value at the top that I can access of the world. Yes, I do. I have the XYZ of the world we are in. So for the people that kind of know programming, this whole like function here, make beam, is called for every block in a schematic. When is new you're working on? I don't know when it's coming out, but I hope it's gonna come out very soon. It's probably gonna come out in like a month. I have no idea, but what we'll see. When using binary world is compatible, then import them using world edit. Yeah, exactly. You understood it correctly, Max. So the middle, so we got this. Wait, no, it's not the x. I'm so dumb. It's the len of world, but I think I have world size. I have a world size variable somewhere. Hold on. I have to. Where is it? Do I have? No, I don't have that. Okay, so I need to use this. It's kind of weird, but hopefully you guys don't mind it. So world size, so len of world. That's gonna give us the middle of the schematic, and then the middle z. So give us the middle z of the schematic. Then, so is it on cylinder edge? So I'm gonna do tolerance. F32 is gonna be. So I like using a tolerance of. So for each block, we're gonna pull whether it's on the edge of the cylinder or not. But the problem is, so imagine we got like our like grid here. So we're gonna like, for each point, for each block, we're gonna check if it's on the edge of the cylinder. So the way you do it, you don't do if like, okay, the equation for a circle is just like, a circle is every point that is at equal distance from its center. So if that is the circle center here, the cylinder, the circle, if we just talk about a circle, the circle is gonna look like this, right? The thing is, to know if a block is within this edge, within like this circle here, within the edge of the circle, you need to check if the middle of the block is, well, equal to the radius of the circle, right? Hopefully that makes sense to the math people in chat. But there's a big problem, is that you can equate it, unfortunately, because if you equate it, then this block will not be taken, this one either, because if you look at it here, it's actually not, it doesn't lie exactly on the circle. So you need a sort of tolerance, which is gonna basically build a sort of like second circle, and if the block is within those two circles, then you're going to what's it called? Then you're gonna put the block in. It's just very important. Otherwise, you have like almost no blocks. So yeah, it's on the tolerance. I usually use square root of 3/2. It's kind of a weird value, but just just trust the process. Just trust the process. It's a value that I chose very carefully. Not really. Forgot the origin of circle. Yeah, Max, you're bad. You're so bad, Max. Max, you forgot. You forgot to include the origin of the circle. Max, Max, you don't goof. You don't goofed. Okay, RSA is here. Bap. That's where the value is. So yeah, tolerance is whatever this thing is. All right. F32. So now, we got the middle and we got all that. So let's. I'm just gonna get like I'm just gonna get a 2D vector. So middle 2D. Middle 2D, 2D vec. Beyond the array. It's gonna be vec. Can I make a vec 3D? I don't have it here. Oh god, I need my new things here. Hold on a second. Is it here? Yeah, like this entire thing. I need all of it. We're gonna remake it. Okay, I'm gonna see I'm tired. Don't forget to sleep. Oh my god. Please don't forget to sleep. All right, you guys need to sleep. Just go sleep, like right now. All right. Good day. Me when rambling about random nerd stuff. Yes. Yes. Exactly. That's exactly the thing. I'm rambling about random nerd stuff, but it's gonna be the vest thing ever. You're gonna see. So vec 3D. Now I can make a vec 3f. My bad, not 3D. 3f with middle x, 0, middle z, and then you're gonna want like pause 2D as well, and then we're gonna compare it against the cylinder edge. In that order. Translate, rotate, and scale. Don't get game burn when not the origin. That's actually I rotate scale. I would actually rotate scale and then translate. That's what I would do. Whereas I actually when talking about redstone, I'm not gonna lie. Thank you. Well, not talking about redstone, but I'm glad. I'm really attracted. Hello, Gear Shift. Hello. So for new people here, again, it's taking a bit longer than I anticipated, but yeah, I'm making a new video and I'm not a good builder, so I use code to build for me. So I already built that offline, and now we're building a big beam that looks good in the middle. That's what we're doing right now. And so I just need to get some formulas in right now. So position vec 2D. So I can probably do F32x 0 and F32z. All right. Oh yeah. I'm glad you like it, Gear Shift. Wait, hold on. So I need cylinder edge, cylinder center. This is gonna be a vector, and then I need the cylinder radius. It's gonna be a float. And I need an XYZ to pull it from, which is gonna be pull from, I guess. So pull cord. Yeah, we're gonna go it like that. We're gonna go it like that. All right. Oh, that's weird. Hold on. Maybe you can do this instead. Yeah, that works. So pause 2D vec. Actually, I want this one. So pull cord 0, and then next one pull cord 1, 2, and then F32 0. As well, I use single plugin first app. I animate chick. Remember making this? Oh, thank you. Wait, I'm gonna show you something kind of cool. I'm gonna show you a data pack that I made for it. So basically, the whole lore of that thing is that this is simulation, right? And basically on this disk, there's gonna be a town, right? There's gonna be a big ass town. And at one point in the video, the town is gonna fall apart. It's gonna fall apart. Every building is gonna fall, and like they're gonna like die and stuff like that. It's gonna be cool. But the thing is, I already kind of made that, and so I think I can actually show you that. And I think you're gonna like it because it's fully a data pack. It's fully vanilla. Before that, let me just replace near. So radius is like 500 gold block to air. Oh gosh, that was a big area. That was a big ass area. Oopsies. Okay, well, it's gonna take a tiny bit, but I think you're gonna like it. Gear shift, Mr. Data Pack guy. Hold on, bro. When is that? When is that when is that getting replaced? I'm like, it's fucking dying. My PC is my Minecraft is fucking dying. The memory is it's getting filled up so fast. Please. Okay. What fun thing can we do while we wait for that thing? I can draw a smiley face. Is it done? It's not. Bro, it's actually taking so long. It's so annoying. Oh wait, yeah. I mean that's kind of normal. Oh, that's okay. Whatever. I can. Oh look, guys. Nothing happened. Nothing happened. I'm just gonna make a Minecraft Among Us. All right. While we wait, we're gonna make a Minecraft Among Us. Hopefully, it's gonna be interesting enough. So Minecraft Among Us. Is it done yet? It's done. All right, it's done. We're good. We're good. We're good, chat. We're good. All right. So gear shift. Are you ready? Are you ready, guys, for the animation that? Because that thing is pretty cool. So yeah, it's a town that just dies. So let me start the data pack. 3, 2, 1. Bam! Here's the town. And look at this. Very gradually, from the center, they're falling. The buildings are falling. And also falling through the world, as you can see. And they're kind of like getting emancipated underneath. So if you look at it, and then we and then shoo, nothing is left. Thank you, Max. I really like it. So that's gonna be one part of. That's gonna be for one part of the video. So yeah, I think that's kind of cool. So yeah, that's kind of what the project looks like right now. So we're making a cylinder now, and I actually need to get to making a cylinder, cause yeah. So pause to the vec, and then I have the middle, which is here, but the middle is actually in here too. So I'm kind of dumb. I kind of implemented this kind of wrong while I was talking. So I just need middle X, but I'm actually gonna be even more cheeky. Since it's on the GPU, I don't really care about performance too much, so I'm just gonna go like that. All right, for people that know coding, don't mind me. Yeah. Looks like you guys like the animation. I'm glad. We're making a custom cylinder. I am making a custom cylinder. But like it's good. The cylinder hopefully is gonna look something like those things. All right, we're gonna try to make it look the same. So we got, okay, so pause to the vec. We got a tolerance that I want to use later on. So here, and so middle X is not used in the radius, is not used either. It's actually gonna be in there. So okay, so is block, so is in. We're gonna do even better. If is on cylinder edge, so the cylinder center is wait, no, I'm a moron. Oh my god, I'm such a moron. I don't. Sure, cylinder center. I actually need it. All right, and I need cylinder. I'm just cutting. Okay. All right, see ya, gear shift. What's happening? Oh, I can't. You can just rewind a tiny bit. You're gonna see a big build, and that's what we're coding today. That's it. I've just explained it. I can't explain it again. I'm sorry. But welcome to the stream. So cylinder center. So center of our cylinder is whatever that thing is, plus the 0 right. Wait, that's not enough. Oh wait, here. I just need this here, and I need this. All right, that is the thing. Okay, so it's cylinder center, and it is on cylinder edge. So we want the cylinder center in here. Then we want the cylinder radius. So that's gonna be 31. That's the radius of the cylinder. Next, we want a coordinate we're pulling from, which is hold on, let me just do that first. Just change that. Cylinder center 0. Next one is gonna be cylinder center 2. And so I'm gonna continue this function after, but yeah, if it's there, center radius, and the pull coordinates is sort of just gonna be vec3f. Can I make just like a pause float? Oh, I think I have float pause in sphere making. Actually, I made it right there somewhere, or maybe in town. Float pause float. No, float pose pause. It's in there. Ah, I got it. Bam. Very important, very cool, and I think I actually have it here. I have it here. Okay, never mind. So float, and then the last thing is the tolerance, which I already have it here. So if our block, so we're like doing that function for every block. If that block is on the cylinder edge, then we do the block at this place is gonna be equal to, what block do I have? Do I have gold blocks? Do I have gold block? Gold? I don't have gold blocks. I'm gonna need to put it. But let's see, what block could we try first? Could probably try like sea lanterns. No, sea lanterns don't look good. Prismarine. Let's do prismarine for now. Prismarine. All right. So we just need to finish the cylinder edge function. So let's see. So distance this to edge. The distance to the edge of our thing is, let's see. So frick. Okay, I'm having a hard meeting. So it's we have the middle. Yeah, okay, yeah. Middle to the vec. So we need sub. So middle to minus the position. We're gonna do that back to doing, yes, pretty much. Here we're not making the animation exactly. Here we're making a big cylinder going through the middle, which is not gonna be animated, not yet at least. So we don't really need a data pack for it. So we got this, and then we need vec length. If the vec length is less then a cylinder radius, no, actually it's kind of the, no, wait, no, this to edge is this, I'm dumb. This is the length. So if we have, imagine we got a circle, shit, like this. We got our center, and we got the coordinate we want to pull from it. So we need that distance minus that distance is gonna give us the remaining distance here, which is our distance to the edge of the circle. And if this distance is less than our tolerance, then the block is within the edge of the cylinder. So this to edge is this, and so return this to edge, ABS less than tolerance. So it's like beam come down, just no, not really. It's just the build that looks like that. Up, and then cylinder radius, and now, haha, we should finally have something. Oh my god. We should finally have something. So if I do this, hopefully Okay, we actually got a schematic created, and this should be an actual big beam. Oh my god, do we actually have a big beam now? Let's go! We got a beam! Oh my god. Okay, this took a while, but it just took a bit of setup. But now, oh my god. Now we're gonna be able to actually make something cool. So if I do paste, I didn't do paste dash A, so it's kind of dumb. Hold on. Paste dash A, whatever that is. And bam! We actually got a beam now. Oh my god. This took so much setup to do, but now we can actually go wild with anything we really want. We actually got... Yes! Max! This is a cylinder! Finally! Okay. With SDFs, let's fucking go. Alright, and normally there should be like, yeah, multiple blocks per thing. Alright! So now, what the hell do we really want with it? Do we want it to follow the gradient of the sphere? Oh, that could be cool if it could follow the gradient of the sphere. Oh, wow. That would look crazy, actually. Thinking about it, that would look crazy. Hold on, let's try that. Let's try that. So if we're going sphere making, we should have some gradient code already done. I think what the modifiers do and what, but it seems like it does something. It does. Dash A. If you do dash A, you paste without the air, meaning like usually air blocks. If I do this paste, air blocks will overwrite blocks that are already in the world, like here, as you can see, right? But if I do paste without the A, that means that like it you know, it does not overwrite the blocks now, and it's really cool. What about an inverse gradient of the sphere? I really like this idea, so we're gonna try it. So let me get which gradient do I want? I'm gonna use this one here, which is the light blue concrete gradient. Yes, it's this one. I just want this one. PyCharm! Yes! Exactly. Hello, Farfel. Big hello. How are you doing? We are actually doing some CUDA Pythoning with Minecraft right now. We are making some builds using CUDA and Python, so it's pretty cool. So let me get some gradients here. All right, and then pop. So let's get which block it should place. So block should place this way cylinder with using smooth noise. This whole thing looks so cool. Thank you. We offsetting the surface is gonna be something. Yeah, I think we're gonna do that. Just before that, I'm just gonna try to make the gradient work real quick, and then yeah, I would absolutely want to do that. So I'm good, and you guys see some numpy and CUDA. Yeah, exactly. Exactly, that's what we're doing. So what's it called? Is it just cylinder gradient? I don't really know how to call it. We're just gonna call it like that. Create cylinder gradient, and I can pull the gradient. I don't remember how I made the gradient pooling, so I'm just gonna have to go back to it. Fuck, where is it? It's here. No. I kind of forgot. Right here, found it. Gradient progress, and there's like a big thing. Okay. So block is equal to this. Oh god. Yeah, I'm kind of dumb. I need to do this, and then the block is equal to this, and this is equal to that. Okay. Alright, so the gradient progress is gonna be kind of interesting. So we're just gonna take the y and then linear map it between the values. Like if the y that we're building at is at like there, it's gonna be 0, and if it's all the way there, it's gonna be 1. So we're just gonna have to do that. So that's gonna be Or maybe make it thicker, thinner using a sine wave. Ooh, yo, you have good ideas. I think that's definitely what I'm gonna do. In like a tiny bit. So the Python gets compiled to CUDA. I don't see the .cu files. It doesn't. I mean, it does, but I have no idea where, and I have no idea how it works. But I know it gets GIT to that. I have no idea. Honestly, don't ask me about technical stuff. I just like dumb my way around APIs, and somehow it works. So yeah. So we go, okay, float pause. The bottom is just F32.0, and the top is F32 len world 0 here. And I want it from 0 to 1. And so the gradient that we want is the cylinder gradient, and we're gonna pull it. Oh, we're just gonna put the random in there, and then we are gonna wait. What the hell am I doing here? X single. What the hell? I don't exactly remember how I implemented that, so that's gonna be very fun. Lens sphere prism gradient. Oh wait, no, okay. Oh no, I get it. Okay. This is gonna be lens cylinder gradient. Alright. So now we should have a gradient. Hopefully without. Alright, awesome. So now we got a gradient. So let's go paste it. So TP in the middle of the world. And then if we get the most recent scheme that has just been created. And paste HSA. Oh. Hey, oh my god. Oh my god, look at that, guys. Oh my god. We actually got a gradient. Okay, without like those like lines here, separation, it looks kind of worse, but like the idea is there. Right, the idea is there. And earlier Beepier said we could have a gradient that's like the inverse of that. So let's try, yeah, having the inverse of that. So gradient progress is equal to 1 minus gradient progress. And let's create another one. So I don't, let's reverse the progress and let's see how it looks. Ooh, oh, that's smexy. That's smexy as fuck, but then it doesn't really match the top. But man, that was a good idea. I don't really know how to like keep it going. I'm not entirely sure. I'm gonna put it back to the normal gradient first, and then we're just gonna like pop. We're gonna put it back to normal gradient, and then we're gonna focus on something else because I actually have no idea what to really do of it. So since we have that, mirror it along the center. That's what I kind of thought about, but it's like I don't think the thing is, yeah, as Beeper said, it's just the contrast up there is just too nah. It's just too much. It's just too much. I think. So we're gonna do something else, which is make the shape of the cylinder be slightly different, which is well, thankfully pretty easy. AKA append the reverse of the gradient to the gradient. That's kind of a smart idea. I like it. Unfortunately, with CUDA, it's extremely annoying. It seems like kind of bold. What does bold mean in that? Like context? I'm not that good at English, so I need some guidance here. I don't really know what you mean by kind of bold. So okay. Yeah, the shape. Let's move. Let's do a shape thing. So I'm kind of thinking of something is to use the noise to transform the shape a bit. So normally I already have some kind of what's it called, Perlin noise in there. I do have Pearly Noise in there. So I just need to set it up. Where do I set it up? I set it up here, and then the seed is gonna be this. It's just like blue concrete. I see again, makes sense. Doesn't look too good if it's just that. Yeah, this gradient here works well on the outside of the sphere because, well, there's like those rivers of light, there's like things happening. I think it's good enough. But you're right, it's just like without all of that, it kind of looks bad. So we're gonna have to change that. But first, yeah, let's change the shape. So I got new Pearly Noise, but domain distortion. Yeah, I mean that's basically what we're gonna do. I'm not entirely sure if it's gonna be domain distortion or it's gonna be a sort of domain distortion. So here I'm just gonna change the radius according to a noise value. So if I do pool noise at like XYZ, so float position 0, float pose 1. There you can calling the center base of the distance from the center. And that could be interesting. That could be very interesting as well. You're right. Resolution. So the resolution is just gonna be like 1 question mark, and Perlin index is gonna be and pedo uint 32 is gonna be 1. Wait, the resolution is this. Oh, we're gonna have to change it later. I had domain sorted in just 5 seconds more than for yeah, it's kind of weird. Add the rivers of light to appear. Yeah, I think that's gonna be a good idea, Max. But at the same time, the gradient idea was really nice, but I think we're gonna need to change the gradient completely because I don't want it to kind of look like I want it to look like very different. I'm not really sure how to explain it, so we're gonna have to change. We're gonna have to change it, but at least the gradient works, so we can make any gradient if we want. Oh fuck, no! I didn't want to open IntelliJ. Ugh, we good chat. If you guys saw, wait, hold on. Did it show the thing? Let me see if it did not. Okay, good. I have like that one project called what's it called, like Sloyme Scam, and they're like Sloyme Scam. It does not. It's not. I'm not scamming anyone. It's just that scam stands for Sloycam or whatever. I didn't really know how to name the project. All right, I'm not scamming anyone. It's just that I'm trying to make a sort of like a replay mod. All right, like a replay mod like mod. Oh my god. So, here we're gonna pull the noise to 3D noise or noise val, float, and then here the oh yeah, I need to change it in this twitch. So the radius used is gonna be, oh my god, I sneezed, my bad. Okay, so the radius used f32 is equal to cylinder radius minus plus the noise value, and we can always do times 4, for example. I think I was scamming anyone before I explained. I know, I know it just sounds more sus that I explain it, but I prefer explaining it. It's just, we never know, alright? We never know. Radius used. Alright, and now we got some distortion going on. So let's see how that looks like. That's gonna be very interesting to see. I'm extremely interested in what the hell that's gonna look like. So undo. And now we actually got some domain distortion going on. So TP. I mean, it's a kind of domain distortion. I don't know how right I am by saying that, but whatever. Okay, so it's doing I'm not sure what it's doing. I think I messed it up. I think I messed it up. Uh, uh, was the noise value not good enough? Oh wait, is the noise value no? Wait, what the hell did it do that? Because I'm literally uh, if I go into sphere real quick. What in the world? I know! What in the world? This is not working. No, I think you're probably talking about that. Yeah, I think that's pretty cool as well. Hold on. So, wait. So, this here. Ah, I keep opening other stuff. This is crazy. Oh my god. We good. So, sphere. So when I was making my sphere here, what's the noise I used? So, I used the noise somewhere. Right here, and noise res is 28. Okay, we're gonna use 28. 28 multiplier. Yeah, that's multiplier maybe. I'm gonna try without first because 3. I mean, that should be that's probably one of the problems as well. Actually, yeah, you're probably right. As high as you can, make it without breaking stuff. Yeah, well, that's basically what I'm doing. That's what we're gonna do after. Here I kind of made it bigger as well, so let's see how that looks. Pap pap, paste I should say. Oh my god, that is wrong. That is wrong, but it looks cool. I don't know what's happening here. Oh, it got out of the world. I need to make the bounds slightly bigger, actually. Oh, that makes sense. Yeah, okay. I need to make the bounds slightly bigger. Here. So I go up here. Yeah, we're gonna go like, I don't know, with 80 times 80, 81. So that is like a middle. That's gonna be better. So it looks like this. I'm not sure. I mean, it doesn't look that good. But if we make the multiplier even bigger. Oh yeah, wait, it actually is because of the noise multiplier. Like it's exactly because of the noise multiplier that's not high enough. And because Perlin noise is like very finicky and doesn't yield big values close to ones often. So we're gonna do like times 12, and here we're gonna have the noise be a bit more compacted together by using 17. So let's create it. Let's undo this and get the new schematic that was just created for us. It's just ready, fresh out of the oven. Paste I should say. That's a bit more like it. That's a bit more like it. Unfortunately, you kind of see the problems with Perlin noise here. It's very easy to see the... Ah, that's interesting. However, it still looks cool though. But you can see there's like, yeah, you can see where it's like around 1. Yeah. It's kind of weird, but it's not that bad either. I kind of like it. Let's try making it even bigger. Or not bigger. I'm not sure, but let's try it. Let's try making it look a bit more natural. The top is still variable. Yeah, I'm doing the shaping right now. It's just easier to do for now. So let's make the noise resolution. Oh, should I use multiple noise values? So like noise val plus equals, and you pull another noise value. You put like the second one, and you half the resolution. That's gonna be very cool. Can you stretch the noise out in the y-axis? Yeah, that's exactly what this is doing, kind of. I mean, I guess. Wait, no, you're right. I could probably do like some very funny stuff. Like I just squish it. Well, stretching out would be this actually. You know what? Let's put random values and just see whatever happens. Whatever happens, man. Whatever happens, just happens. All right. You look like demo scene stuff. Instead of using similar methods, you should make a demo in Minecraft. Demo scene. So if I remember correctly, I already started making that. I started making a whole UI to do something like this in Minecraft. I could probably show it here. Yeah, it's here. If you go there, this is a sort of like I started making a sort of like program to like make demo scenes in Minecraft. So like you edit your demo scene here, and then at the end you can just save it to a data pack that would play in Minecraft. So like you have like the sound here, like so that you can like sync it, and you can see it's like down to the tick here. These are ticks right there. And so yeah, if I play from here, you can hear it. I think you can hear it on the stream. Yeah, you can hear it. Sorry if it's a bit loud, but yeah. I actually started making that, Max. That was very funny. Anyway, let's go back to our sphere. And let's see how the latest schematic looks like. So hopefully it should look kind of good. No, it does not. It does not. It looks no. Okay, it looks not. It's giving me trypophobia. Oh, that's so cool. Should make it exponentially noisy. Like, oh, make it more and more noisy the more you get to the edge. Oh shit, that's an idea. I really get behind. Noisiness is gonna be so okay, how we're gonna do this, I'm just gonna compute the noise here. The noisiness is gonna be linear map a value, which is gonna be float pause 1, which can go from 0 to the length to the y of the world, and then make it exponentially noisy. So you want something. So I'm gonna put it firstly between 0 and then 1, right? That makes sense so far. I didn't make a mistake. Now I want to mirror it. Oh wait, no, I can -1 to 1. Then the next thing is that you want to apply some kind of like noisiness to it, so to like some kind of like exponential curve or whatever on it. So the way you would do that is by doing I think it can be good beeper, to be honest. Beeper, beep 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 noisiness. So if I well, oh yeah, and then just do noisiness equals ABS noisiness, so that it's now it's all positive, and then noisiness equals noisiness cubed. I think that could look cool. That could look cool. I'm not sure about doing all that. I'm just gonna smooth it out again. It's gonna be a bit easier, but we're not gonna be too times as because I probably forgot to do this. All right. So now, oh yeah, and I forgot to do the final noisiness thing, which is that either times noisiness. All right. Well, I can actually do it elsewhere, like noise val times noisiness. Let's see how that looks. That's gonna be very interesting to know how that looks. I don't know how that looks. Do you guys know how that looks? I don't know how that looks. Let's find out how that looks. Paste, I should say. Bam. So the more it's on the outside, the more it's noisy. I think my noise is not powerful enough. I need a bigger noise multiplier or something. Whatever. Let's firstly put 2 instead, and let me make my noise multiplier noise multiplier, and that's gonna be I'm gonna put like I'm gonna go out and do 16, and then noise val, and so noise val times noise multiplier. Okay, let's find out. Here, bam, down here, TP to the middle of the map, get the latest schematic, and we paste it in. Ooh, that's interesting. That is interesting, but now we can definitely stretch it on the y-axis, which is probably a good thing. Let's see. So yeah, to stretch it on the y-axis, what I was gonna do, y f32. I'm not sure. Do I just do divided by 3, and I'll do that, and I'll do like stretch is equal to 3, and here we just do overstretch. That's probably what we want to do. Let's see what that does. Hype. All right, so again, TP middle of the world, get the latest schematic, and then we paste it in. Here we go. Here we go. Ooh, that's so interesting. Okay. It's kind of sick. It's getting kind of sick. Maybe let's do like let's make the stretch be like 2. I'm gonna change where the noisiness is like computed as well. I'm gonna put it here. I'm gonna put the noise multiplier up here, and I'm gonna add a little space just so that it's like so there's like 2 places where stuff is happening. Let me try removing this noise value. All right. Maybe it was a good idea. Yeah, it was. That's what I've been saying. Paste, I should say. And ooh, oh yeah. Oh, that is really cool. Oh, that looks kind of cool. Why does it look off center? Why is it off center? It kind of looks like the sphere stack on top of each other. Yeah, it's a byproduct of Berlin noise. It's a bit annoying. But wait, first there's just one problem. It does not. Yeah, it's not centered. What the hell? Why is the noise not? Why is the thing not centered? Oh God, the whole cylinder is not centered. What did I do? Why is that? Okay, that's gonna be interesting to debug. Even because of the noise. You think it's off center because of the noise? Because the noise only doesn't warp where the X, Y, and Z is. It warps the radius. So that's why I don't think that it's off center. That's why I don't think it's Y, but cause like gotta adapt the move stage. I gotta adapt my like in my head. All the math is not supposed to make it off center, which I think is gonna be better to debug first. Oh gosh. Just comment noisiness and try. Yeah, let's not put any noise and just see what happens. Yeah. Radius used is just the cylinder radius. You're right. Let's try. Let's debug one by one. TP middle. Get the latest schematic. And here we go. Here we have it. No. Okay. Okay. It's not the noise. That's what I was thinking. It is not the noise that makes it off center. It's just me. Oh, I know why. I just found out why. It's because earlier, you see, I bumped up the world size from 63 to 81. But the thing is now the center kind of moved, and so I need to change this as well. So it's just world size 0, and then world size 2. There is slightly, and then the last one is world size 1. And yeah. So now, if we just regenerate it real quick. There. Paste, I should say. Bam! It's centered. Yay! It's centered. Yahoo! Alright, and now, finally, we're gonna be able to, yeah, we're gonna be able to put the noise back. So let's put it back. I don't remember where it was. Was it like down there? It was right here. I just, where is it? Right there. Alright, here we go. Alright. So now, let's get the latest cam. As usual, it's a routine now. You guys know it. Get the latest cam, go to the middle, and paste. And now, ooh, that's interesting. That is extremely interesting. I'm wondering, what if we made? Okay, hear me out. What if we made the top of the cylinder go like in an arch, like, you know, like this, right? What if we made it go in an arch like this towards the top? You guys think it's a good idea? I think it would be a really good idea to do this. And here, I think I know how to do that as well, so that shouldn't be too bad. Ooh. Oh god. Water time, but yeah. I think that's gonna be sick. Okay, let's do that. Let's do that. That's gonna be super sick. So we want another value. Yeah, low structural integrity. You're right. So what we're gonna do is change the radius as we go up the cylinder. So let's see. So radius use, and we're gonna do. So this is the whole noise thing. So noise thing, and this is gonna be the what's called cylinder warping, I guess, towards the opposites. That's why you can, yeah, towards the opposites. All right. So okay, how do we do this? So warpness, let's call it warpness, is gonna be something very similar to noisiness, because noisiness, what does it do is it, like, as you get closer to the sphere, you're gonna have more noise. But in this case, it's as you get closer to the sphere, the more you make it stretch, which is actually pretty easy. So this is the warpness, and warpness, you do the same thing as you did here, that you do here, actually. But oh no, equals ABS warpness, and then the next part warpness, and then if you compress a stretch the board, you can make it look like look like strips coming down. Yeah, it could be, radius, something like, smoothly interpolate between sphere and cylinder SDFs. Smoothly interpolate between sphere and cylinder SDF. I'm not gonna do that with the sphere. I'm just gonna do a very simple thing, which is, if I can't, I don't exactly know how to explain it. We'll see in a tiny bit. So I don't really know what you mean, Flash, but by strips coming down, but can you try to explain it a bit more? Because I don't really understand it. Okay. So warpness. So let's see. So warp final radius is gonna be, so the warp final radius is how big our cylinder needs to be at the very top, which is like, this is 31 at the start, and I guess we could like multiply by 3 or something. So cylinder radius times 3 or something. Yeah, times 3. This sounds good. How about barbershop light rivers, like those barbershop whole things? Like candy cane is a better example. Ooh, yeah, yeah. That was something I was thinking about. That's probably something we should do at some point. I don't exactly know how to do it, but I really want to do it. I really, really want to do it. So warp. Let me just do this first. So warp final radius, and then let's see. Yeah, warp final radius, and then oh yeah, then we just do plus warp final radius times warpness, and that's it. That's all you do. So that the noisiness becomes like 4 blocks white strips that makes their way halfway down the cylinder. I still don't understand it. I'm sorry. I'm probably just dumb, but they become like 4 block white strips like that. That make their way like halfway. I'm sorry. I don't really understand it. Ugh. Sorry. Warpness, finally. Okay, let's see how that looks like, real quick. Okay. Oh, the schematic's probably not big enough. I need to make it even bigger. That's funny. That's extremely funny, but it's fine. Let's just see how it looks though. Okay, yeah, okay, it's already doing it wrong. Okay, it's already doing it wrong. Let me do 4 first to like make it start later, and then I need to make the world bigger. And since I'm doing like times 3 here, we're just gonna make the schematic 3 times bigger. So like times 3 times 3. That should be fine. GPU start. All right. So let's see on the schematic schem list. Load this, and then I'm doing this. Yeah, it's really hard. I mean, especially through YouTube chat, it's really hard to do this kind of thing. But let's look at our cylinder. Okay, what did it do exactly? Ooh, that's interesting. Oh my god! Wow! Holy crap, does that look good at the bottom? What the hell, man? What the hell? Ooh, that's very smexy. Damn. I guess you have smooth blend with the sphere would probably be slightly better, but like it's smooth enough, especially if I change it slightly more. If I go down to our code here and I make the what's it called? Is it going through the sphere at the top and bottom? It is. That's what we're gonna have to fix after. But it is. The bottom is proof that the top needs more texture. Yeah, you're completely right. But let me just do that first. Okay, so yeah, I want to make it so warpness strength. No, warpness interpolation. No, it's not. I don't really know how to call it. It's like this value here. Warpness start. We're gonna call it like that because I have no idea how to call it otherwise. Alright, actually I'm gonna make it 6 instead. I thought you like us pretty cool. But yeah, I know, right? Beeper. It's so true. That's like exactly what happens. It looks so cool. The bottom looks so cool. Please, I should say. Oh yes, yeah, slightly better. Yeah. Please make an execute. Please do make a comment execute all the undo TP. Can you explain the new watches what you're doing, please? All right, so this is for the new video. I'm making a new video. It's heavily low based, and I need builds for it, and I'm not really good at building like by hand, so I'm using code. I'm using like my own like sort of like engines and stuff like that to actually create schematics with code with my GPU, so that like I can then make beautiful structures without having to build it by hand. That's basically it. I want to change the noisiness slightly. So if we go here and we go noisiness here, noise multiplier. I want the noise multiplier. And I put 32. What happens at noise multiplier 32? I'm really wondering. Is it gonna frick up the whole thing or no? We'll see. All right, here we go. Let's see how more noise affects it. Ooh, yeah. That's pretty cool. Oh my god. I don't really know why. I don't think I can pinpoint exactly why, but this top structure here just makes me heavily uncomfortable. I don't know what it is. I'm not sure, but it makes me uncomfortable. I don't know why. Oh, I knew it would fuck up. I knew it would fuck up here. If you modify the radius. Okay, yeah, okay. It's kind of reassuring to see this bug because I really was expecting it to happen. So, okay. I just need to make 200. Do you share the code somewhere? Because it looks really good. Thank you. Maybe. I'm not sure yet, but it's maybe gonna be released with the video. Wow, Viper, what did you send? The hell did you send? No. Look, oh my god, look what he sent. I swear to God. I do not like kissing boys. What is this? Beeper. I'm never opening any of your links ever again. That's horrible. Oh my god. Let's get back to building. I need to clear my head from that. That was traumatic. Alright. So this is cool, but okay. I want kind of like a completely different sort of gradient for that thing. I still want it to go to black down here, and then maybe change the shape there, because as I said, it kind of makes me uncomfortable. I don't know what it is. I don't know what it is, but I really don't like it. So I don't really know how to do it. It's here. It's in warpness, and then I just need for it to stay at 1 if the y is greater. So if warpness, if float pause y is more than 0, warpness equals to 1. I think that's gonna be. I don't know what it is again, but I don't like it. Ew. All right. TP. Oh God. Uh-oh. Uh-oh. Oh, that's wrong. That is really... Wait, that's... Okay, something is wrong here. Something is wrong here. Oh, I need a 0. Otherwise, it's kind of wrong. Oh my god. Okay, that's dumb. That's dumb. Let's regenerate it. Hello, El Puleto. We actually made quite the progress on the beam. We actually did make quite the progress. So if we go here, base, that should say. Now currently our beam looks like this. So oh god, oh whoopsies, what is this? I actually needs F32 len world 1 over F32 2. Let's go 3 pillars. No, Peeper, that's not what we want. That's really not what we want. Oh my god. List. Bah. Alright. And so up here we have no Beeper. I remembered the incident that happened 5 minutes ago. I'm not opening the thing again. Alright. I'm just not doing that. If you think I'm gonna do that, you would be mistaken, because I will not. I am not dumb. I know, you know what? I need to know what that is. No! Bro. Beeper, what is this? I hate you, man. I hate you. Oh my god. I'm just gonna continue making a pillar. I'm not gonna open the thing. By the way, instead of dividing by 2, it's so frustrating. Wait, where? Like here? What is wrong with this? So first off, dividing by 2 is, what's it called? More accurate in like float arithmetic. And also, what's it called? I don't really care about performance because it's running on my GPU anyway. It's like, it's so fast. I don't care. I do not really care about that performance hit, to be honest. So I don't really know why else you would be frustrated by that, but hopefully that clears up things, and maybe it's just something that you do and I don't. We're different people, you know. I did not need to take it so seriously or whatever. The reason my screensaver making a dead in the screenshot was taken seriously. Could be it. Yeah, that's a very funny way to hijack it. Oh my god. Okay, so so yeah, we got this thing happening here, and there's just that one thing that is a bit annoying. You know, if you go down there, you can see that the thing, well, firstly looks like shit, but also, yeah, is like outside of the thing. So we're gonna have to, we are going to have to modify that. And I don't really remember. Wait, hold on. I actually remember. The sphere is 160. No, 4. Fuck. But it's going to sphere. I think there's probably 2 4. Yeah, right here. Sphere radius is this. So we're gonna do something very interesting here. We're gonna do, if the float, so center, is there, yeah, center sub float position and the length of this. All right. So if the length of the vector from the center of the world to the middle is less than the sphere radius, is more than the sphere radius, return. You don't do anything in that shader anymore. Yeah, I think person is print. Yeah, fair enough. Hello, Mr. Herobrine 15. So yeah, we all right. So now we should actually have our thing not getting outside, I guess, not being built outside of our sphere. So it's good. Let's try it. Scam list. We paste it. And so if we do this, look at it. Now we should still have the shape here, right? But then if we go outside, bam! It does not, it's not, yeah. It's perfectly inside the sphere. Let's fucking go. I'm like I'm so good at coding. Oh my god. Okay. That is awesome. That is awesome. We did really good. One last thing that we need to check in is that one bug with the radius. So it's just, I think I just need to make tolerance a bit bigger. Like here, tolerance, and then go here, tolerance. We're just gonna times f32 3, for example. Now it's inside the sphere. You're right, Beeper. It is inside the sphere. Isn't that crazy? I think it's crazy. I love how crazy that is. I'm kind of crazy lad like that. Just gonna go here. So yeah, for other new viewers coming in right now. We are coding my next video, and we're actually building with code. So this is something I built a while ago, this sphere thing, and here we just we are building this beam in the middle here using code. So I hope it's gonna be very interesting. So wait, so is the tolerance bigger now? Hopefully there should be more blocks. Yes. Yeah, oh yeah. Yeah, it's so much bigger. And so now there should not be any holes in the structure here. There should not be any. No. What's the light blue disc? Light blue disc, El Pleto, is where the town lies. I can play it for everyone on the stream right now. I can play the animation again, but basically in the video I'm making, there's a part where there's like this town, and like this, this whole thing is a simulation basically, and like the town, there's like a town on that disc, and it's basically going to fall apart. And so I already got the animation for it that plays with the data pack, where if I just go back a while, that, oh wow, oh my god, it's been so long since I played it. Yeah, okay, I got it. Yeah, I can play the animation, which is, yeah, the animation is just the town basically falling apart. So here, if I play it, you can see the town I was talking about, and then it's gonna fall apart from the middle. So you can't really see it just yet. Okay, and now it's, yeah, you see all the builds are like falling. Like this one, look at it, it's falling like that, and it's falling on the ground, and like it's traversing the ground. Like every build is doing that, as you can see. And what I really like as well is that when they traverse the disc, they actually like emancipate like that, which I think is really, it looks really awesome. I'm really proud of this little thing. When is the video coming out? The video is coming out in, I have no idea. I don't know. I'm not gonna set myself some release dates yet. It will come when it will come. I can't really tell you guys, because I'm not sure myself. So, all right, and so now that we kinda got the shape of the cylinder, I kind of want to have sort of like different kind of a gradient to it. You know, I want it to fit with the sphere. So down here and up here, like I want this to be kind of blue, and I want this to be kind of black, like it is. But in the middle, I would want something more yellow, or maybe red. I'm not sure. I kind of wanna find out how that would look like. The town doesn't make holes in the cylinder. Yeah, we're just building the cylinder now. I'm not really I'm not going to worry about that yet. There's a time and place for like every problem that this thing has, and I'll solve that later. It's not too hard to make to not make the town like go through. So it will be fine. Don't worry about it. All right. So now, let me check. Yeah, okay. So we were talking about gradients. So let's see what kind of gradients we could have. So would you guys see for like such a cylinder here? Like the cylinder is basically in there. There's basically gonna be what powers the simulation basically, and like the lore kind of shit. So I don't feel like making it the same color as the sphere is like a good idea. It's like this thing is special, you know? This cylinder is hella special. I don't think making it the same as the sphere is a good idea. In terms of coloring. So what do you guys think? Would you guys vote for more like yellow or like red colors? Because I'm definitely not sure what color to use here, because it's a very weird build. See, colored, we go, yeah, red, yellow. Which one looks the best here? Would yellow look better in the build? Let me. For a beam, maybe go red. Go red, alright. Let's try red. And let's see what like colors. Like yellow seem more powerful, but red will look cooler. Alright. We're gonna try with red first then. So let's see, what kind of gradient do we want? So we want this. See, the center of the earth is lava. Oh, that's interesting. Oh, so we could maybe make it orange. We could try. Let's I'm gonna go on Hue Blocks real quick. Hue Blocks. If you don't know about it, it's a website that makes you able to like transform some kind of gradient into blocks. So I want I want like black concrete. Hold on, so where is it? So I want black. No, I don't want the block itself. I want to my color the color itself, and then I want it to go towards a more red kind of thing. So let's go red, not full red though. And then 25, and so we got this thing here. Shroom Light as the last one. Maybe not Shroom Lights. Hello, Al. I'm not really sure how to pronounce your name, but hello. We are coding some building. Hey, we are making builds with code. It's pretty awesome. So we got that gradient. That gradient could maybe be cool. Let me try to think. So we got black concrete, coal, nether brick, black terracotta. Wow, that's interesting. Crimson stem, Nelium side. Yeah, I'm just gonna put netherrack to be honest. Or just not put anything. Strip mangrove, red terracotta, concrete powder. I don't really want to, because like it's just gonna fall. Then we got this, and that. And then I just realized we need like a sort of three-way gradient, right? I'm gonna keep this gradient for the red. I'm gonna put it in here. I'll put it there. Let me go image. Let us get like more space. All right. So, and then I want another gradient that goes from here. Fuck. Yeah, I mean that's 82, so it should be easy to remember. So red to with like 82, right? And then here I want another block which is more like the sphere right here. It's true, like an energy concentration. Yeah, that's interesting. Let's use like this. Actually, I'm gonna use a specific block I want to get to, which is light blue concrete right here. Honestly, yeah, I could try. That's why I'm keeping it just in case. We'll see what happens. Oof. Oh my god, that's like, oh, that's an ass gradient. Oh, that's actually really bad. Oh wow, in programmer's art it's like way easier. But this, oh, Oh, this is terrible. This is terrible. This is so EU. Uh, so you can't really gradient from red to blue here. Ah, I don't really know how to do that. I have to figure it out. But it's been 2 hours. I gotta either take a break or just call it here for today. I'm probably gonna continue off stream, but that was honestly a very interesting stream. I didn't think it would like go that well, and that like you guys would be that involved into making whatever the fuck that is. So that's pretty cool. But yeah, thanks for tuning in. Hopefully, I showed you guys something pretty cool, and I'll talk to you guys. Talk to you later. That was awesome. Thank you for tuning in. That was really cool. Yay, Screeny group photo. I mean, you guys are not there, but you know, just imagine. But yeah, thanks so much, and until next time. See ya.